All right, in this video, we're going to look at coterminal angles and how to find them. So in our last video, in example 3D, our angle delta made one full rotation and then went and ended up on the negative y-axis. And it turns out that what we're going to look at today is how to be able to sketch this quicker in terms of where the terminal side needs to be, just based on removing full rotations in either direction until we get something that's usually between 0 and 360 degrees. So two angles that have the same initial and terminal side are called coterminal angles. In other words, think of it like if you spin a spinner and it goes around once and ends up where, maybe on a blue wedge, and then you spin it again and it goes around like 5 or 6 times. If it goes around 5 or 6 times and still ends up on that same blue wedge, it doesn't really make it any different than if it only went around once. And that's what coterminal angles are. They disregard any full rotations that happened for the angle itself, and they only care about the terminal side and where it is, excuse me. So to find coterminal angles, we're either going to add or subtract multiples of 360 degrees or 2 pi radians to the angle we have. So with coterminal angles, whatever units we are given at the start of the problem, that's what our answer has to be in. So if we're given degrees at the start, our answer has to be in degrees. If we're given radians at the start, our answer has to be in radians. So example 4, find a coterminal angle between either 0 and 360 degrees for degrees, or 0 and 2 pi radians for the radians. So we're going to start with 400 degrees, and 400 is above the 0 to 360 range, so if we remove one rotation, we can take 400 and minus 360 degrees from it. A 400 degree angle is going to have the same terminal side as a 40 degree angle. So in terms of knowing where the terminal side is, 400 degrees and 40 degrees have the exact same terminal side location. All right, part B, we have negative 4 pi over 3. Now, you could convert this to degrees, get the answer in degrees, but then you would also have to remember to convert it back to radians. I, on the other hand, just look at it as negative 4 pi over 3. If we add 2 pi to that, and if 2 pi is 6 pi over 3, so negative 4 pi over 3 plus 6 pi over 3 is 2 pi over 3. If you had a little bit of fraction phobia here, you could take negative 4/3 and add 2 to it and ignore the pi's. You'll get 2/3 when you take negative 4/3 plus 2, and then just put the pi back when you're done. So either you could do that or just get a common denominator and either add or subtract. But yeah, 2 pi over 3. So if you converted this to degrees first, I believe it's negative 240 degrees. Add negative 240 degrees to 360 degrees, you get 120 degrees. 120 degrees in radians is 2 pi over 3. So you have that alternative. You just got to remember to convert it back when you're done. Part C, 9 pi over 4. So we subtract 2 pi from that, we get pi over 4. So take out a full rotation, we get pi over 4, and we're good to go. Part D, negative 785 degrees. So if we add 360 to negative 785, we're not between 0 and 360 yet. We actually have to add 3 rotations in order to get between 0 and 360. So depending on how large the angle is, whether it's large in the positive sense or large in the negative sense, you might have to add more rotations than just one. So we might have to add 360 and then add 360 again and then add 360 again in this problem. Or we might have to subtract 2 pi and subtract 2 pi and subtract 2 pi. That's perfectly reasonable, and it does happen quite a bit. So if you're not there after one rotation, just keep going until you are. And when we get our answer here, we get 295 degrees. So a 295 degree angle and a negative 785 degree angle are going to have the exact same locations for their terminal sides. All right, so that about does it for this video. Thanks for watching, and I'll see you next time.